All right, let's look at a few questions as we look at the geometry of 2D shapes. Okay, you can use your textbook on page 147. All right, so we have this question here. You have that first triangle, and the instruction is to find the angle theta. And when we answer such questions, please understand that we have to write the reason for every statement or for every action you take. Now, if you look at the first triangle there, we have three angles. We have 70, angle A. We have angle B, which is our theta, the one we do not know. And then we have angle C, which is 64. Now, the property that you would quickly think of here of a triangle is that the sum of angles in a triangle should be equal to 180. So we know that the sum of all the angles, sum of angles in a triangle should be equal to what? 180 degrees. So therefore, I will then say theta plus 70 plus 64 equals to 180. Now that is my statement. How would I then put this together? I have my statement. Let's move the statement to one side. And this is the reason for saying that that statement exists. All right. Just need to move this nicely. All right. Good. So we know that the sum of the angles in a triangle is equal to 180 degrees. And what do we need to do here? We just need to ask our calculator for help by adding the 70 and the 64 and subtracting that from 180. Let me get my own calculator. All right. So I will then move those other numbers to the other side. So it becomes minus 70. All right. When the 64 also goes to the other side, it becomes minus 64. Remember, when the positive goes over, okay, it becomes a negative. What is my answer? My answer is 46. So my theta, therefore, we can then write our final answer. Theta equals to 46 degrees. And we are done. All right, I hope that makes sense. Let's look at question number 2, the second one. All right, the first thing that catches my eye here is that I am dealing with a right angle triangle. And how do I know that it's a right angle triangle? Look at this symbol there. That tells me that's a right angle triangle. And the angle there would be equal to 90 degrees. Right. So you see that symbol there? That tells you that's 90. Again, this is a triangle. All right. We know that angle A plus angle B plus angle C should be equal to 180. But already C is 90. It means that all I need to know that is A and B will now be equal to 90 degrees, because the 90 here and the 90 there would give me my 180. Okay, there's a very important information that is given to us here. There is a 7 here and there is a 7 here. So two sides are equal. What type of triangle will this then be known as? This is known as an isosceles triangle. And what do we know about an isosceles triangle? Two sides are equal. Therefore, we know that two angles are also what? Equal. Two angles are equal. All right. Can I therefore say that angle A will be equal to angle B? And what is going to be my reason? We would say that angles opposite equal sides. So the angles that are opposite equal sides. So check this. This side, this is what we're saying. Let me have my highlighter. So this side, all right, is equal to the side, and this angle is opposite to the side, all right. This angle here is also opposite to the side. That's why we say angles. So the angles that are opposite the equal sides. So angle A is also theta. What does that then mean mathematically? It simply means that, let's check now, my A would also be then theta. All right. So theta plus angle theta plus 90 would be equal to what? 180. Now, what is the reason? Sum of angles in a triangle. Sum of angles in a triangle. Oh, theta plus theta will then be 2 theta. All right, can I move this 90 over? It gives me 90. And then I can divide both sides by 2. Theta therefore equals to 45 degrees. That's very easy to do now. Okay, all right. And you know we can get the length of AB as well by using our theorem of Pythagoras, because it's a 90 degrees. So if I wanted to calculate the length of AB, let's just get an extra page. If I want the length of AB, the length of AB, all right, then let's go back and see what the diagram looks like. Oh yeah, let's do something here. Let's copy this diagram here. Okay, and let's go over to our second page and paste. Beautiful stuff. All right, so let's get the length of AB. So because it's a 90 degrees, we know 90-degree angle there, we know we can then work with our Pythagoras theorem, or theorem of Pythagoras. And the longest side, which is the AB, so AB squared is the longest side. Why is it the longest side? It's the one facing, all right, it is the angle that is opposite my 90 degrees. All right, the angle opposite here is 90 degrees, so it is the longest what side. And that's one thing we must not forget. That's the hypotenuse, the longest side, and that therefore should be equal to AC squared, the sum of the other two sides, BC squared. So AB squared, if we then substitute 7 squared plus 7 squared, and 7 squared will be 49 plus 49. This is AB squared. Now 49 plus 49, that will give us 98. All right, so AB squared. Now how do we get AB? We look for the square root of both sides. So AB will be equal to the square root of 98. And you can leave your answer like that. Let's find the square root of 98 to make it easier. Okay, we still have our calculator here. Square root of 98 would be 7 root 2. All right, I like the 7 root 2. All right, so this is going to be 7 root 2 centimeters. You can see it's actually longer than the two sides. Let's go back to check the value again in decimals. Oh, it's almost 10, 9,9. All right, 9,9, which is almost 10. So you can see that it is the longest side, longer than the other two sides of 7 centimeters. All right, look at this one here. All right, this is question number 3. We are looking for angle X. All right, there's a property of a triangle here that we need to know, that the sum of the opposite angle, the sum of the two opposite angles is equal to the exterior. This is my exterior triangle. It's outside the circle, but on a straight line. You see, AC is a straight line, and X is not in the triangle, but on the straight line. So it's an exterior. All right. So we can therefore say that A plus B would be equal to X. All right, exterior angle of a triangle is equal to sum of opposite what? Opposite interior. All right, so what is my X therefore? 73 plus 43, and that should be equal to X. So what is my X? My X will therefore be 116 degrees. All right, X is 116 degrees. There is another way to get that done. Let me try to use a different ink. The idea would be to get that angle there. All right, so can we say angle C inside? All right, so this is me working out something else. A plus B plus C would be equal to 180. And what is the reason? Angles, sum of angles in a triangle, right? So if I then have 73 plus 43 plus C would give me 180. Okay, what is my C therefore? I've got to move my 43 and 73 over to the other side. So 73 plus 43, let me see, 180 minus all of that. Okay, let's do this. 180. So if I move the 73, it then goes over. If I move the 43 as well, it also goes over. Okay, and my answer is 64. But that is the angle inside, the yellow one, 64. Now, do you notice that this angle here and X is a straight line? And we talk about adjacent supplementary angles. So C plus X equals to 180. Adjacent supplementary angles. So 64 plus X will therefore be equal to 180. What is X? We can then throw the 64 over to the other side, and what are we going to have? 180 minus 64, and that will give us 116, and we're back at the same answer. Beautiful. I hope that makes sense to us. All right, so either we use the first method or the second method. Okay, all right, I'm just going to clone this page and take all of these other ones out so that I can have enough space to deal with the question below. Okay, now what do you notice here? I notice I've got a right angled triangle somewhere. All right, let me use a highlighter. Okay, I've got a right angled triangle there. Okay, so that tells me that's angle 90. However, let's get all the information first. We're looking for this angle, but I do not know this angle. All right, it's a multi-step thing. Let's check. I know this 160. Oh, this is a straight line. Adjacent supplementary angles must give me 180. Beautiful stuff. So that means I can get my C2. That's the first thing I'm going to go look for right now. All right, so C1 plus C2 equals to 180. All right, adjacent sub angles. My C1 is 160 plus C2, and that is 180. So what is my C2? 180 minus 160 will give me what? 20 degrees. All right, but that's not what I'm looking for. Remember, I have this as 20 now. Okay, let's write it there with a different ink, since that's what we're calculating. This angle is now 20. Oh, look at this symbol. I'm seeing a symbol here that could help me. That and that tells me that the two sides are equal. Oh, if the two sides are equal, then we can look for angles opposite. This is an isosceles triangle. Okay, which side or which angle is opposite this? Let me let this then go. All right, look at the side. Which angle is opposite? Oh, it must be this one. All right, opposite that side. Okay, let's check something else. This the second side. All right, which angle? 20. Oh, those angles must actually be equal. Oh, you know what it means? It means now that my angle D, is equal to angle C2, which is equal to 20 degrees. Angles opposite equal sides. Now that I have my 20 degrees here, all right, let's write the 20. Again, it's an angle that we're not given, but we have been able to find. Oh, my angle A now, check this, my angle A plus angle B plus angle D should therefore be equal to 90 degrees, sum of angles in a triangle. So what is my A? My A is 90. What is B? Theta. And what is D? 20. Oh, not 90 degrees here. This should be 180 degrees. All right, that should be 180. So what do we do? Can we move the other angles over to the other side? So 180 minus, if I throw the 90 over, and if I then throw the 20 over, 70 degrees. Beautiful. And that's it. So sometimes you've got to find certain angles to use them to find the other angles. All right, beautiful question. Let's look at another one quickly. Oh, they look scary, but don't be scared. Let's check what we can then do. We are looking for this angle theta here. We're looking for theta. Where's my highlighter? Let's go look for that highlighter. All right. So I'm looking for this angle here. Wait, I see the symbol. Okay. I see that symbol, which means that the angle opposite the side, theta, must be equal to the angle opposite the other equal side. Oh, so this angle here is also theta. That's what it means. Let me write that with a permanent ink here. All right. So number one, I know that my C equals to D2. Angles that are opposite, two sides that are equal. Angle opposite equal sides. All right. Now, I haven't said that. Let's see. How do we, what is the meaning of this 52? Wait, I'm seeing something else. The side is also equal to the side. Oh my word. So then it means that, check this, if the side and the side are equal, let's go check something. Where is the angle opposite the side? It is this, opposite, right? Opposite that side. Okay, what about this one here? Opposite the side. All right, so we look at the two sides that are equal, all right, and look at the angles. Okay, I see what to do. So what it means is that angle A, now I need a permanent marker now. Angle A is equal to angle B1. Again, angles opposite, equal sides. All right, awesome stuff. Okay, now if I have this angle A and B, but I know that A plus B1 plus 52 should be equal to 180 degrees. Angles in a triangle, sum of angles in a triangle. All right. Okay, now, but how will this really help us? Will this really help us? It should help us. Let's see, let's get angle A. So can I say, since angle A is equal to angle B1, I'm just going to replace my B1 with A, plus 52 equals to 180. So A plus A would give me 2A equals to, I can then move my my 52 over, it becomes negative 52, and then we have 128. Can I then divide both sides? A would be equal to, if you divide that, that would give you 64. Let me write that in a different ink. This is 64. This is also 64. All right, now let's look at the bigger triangle. Let's look at the bigger triangle. Angle A plus angle C plus the whole of angle D should be equal to 180, the bigger triangle. All right, so if I have that, A plus C plus D should be equal to what? 180 degrees. What is my angle A? My angle A is 64. What is my angle C? Theta. What about my angle D? Look at your angle D. It's a big angle that, made up of two angles. So we have 52 plus D should be equal to 180. Don't forget here, sum of angles in a triangle. All right, so we can work out the mathematics here by adding our 64 and 52. All right, and that will give me 116. All right, 116, and theta would give me 2 theta. So we can then say 116 plus 2 theta equals to 180. So 2 theta therefore would be 180 minus 116, and that will give me 64. And we can then divide both sides. What we have, 32 degrees. I love this question. It's quite a multi-step question, so you've got to think through first, look at the symbols that you're given, and that will guide you and help you walk through. Look at the symbols, interpret, make sure you remember all the properties of the triangles that we've spoken about. All right, so we have that. Let's see. Oh, this is a parallelogram. All right, so we are given A, B, C, D as a parallelogram, and we're supposed to find the value of angle X. Okay, what can we see here? Number one, remember your fun. If it's a parallelogram, then this must be parallel to that. And if that is parallel, I've got this interior angle here. It means that B2 equals to 30 degrees, and we say alternate what? Angles. So this angle here is 30. Oh, I'm looking for X. Oh my God, I see something here. Beautiful. Which means I can get C1. All right, C1 plus, it's angle on a straight line, right? But we don't want right angle on a straight line. C1 plus C2 equals to 180. It is adjacent supplementary angles. Let me get a white chalk here. All right, so what is my C1? I don't know, but I know this as 142 equals to 180. So I can get C1. All right, 180 minus 142. 38. Oh, so my C1 is 38. Now it's easy. I know that my B plus C plus D, look at that, it's a triangle. Angle B2 plus angle C1 plus angle D2 should be equal to 180 degrees. Sum of angles in a triangle. Sum of angles in a triangle. What is my B2? 30. What is my C1? 38. What is my D2? X. Oh, now we are done. I need to move the 30, 180. I need to move the 30 and the 38 over to the other side. Both becomes negative, and that will give me 112. Easy stuff there. Look at this. Again, we're given that it is a parallelogram there. All right, so this side is parallel to that side. And don't forget that the angles opposite in the parallelogram are equal, so that will be 120 as well. Okay, all right, so B is equal to 120. Opposite angles of PAM, PARM. We just write it like that, it's fine. Now, I want you to see something here. Because these lines are parallel and there's a line joining them there, a transversal line joining them, this angle will be equal to 2x alternate. So A2 is equal to 2x alternate angles. Now, if you then check, we've got a triangle here, ABC, which we know that would give us 180 when we talk about the interior angle. So A plus B plus C, let's be specific, which A? A2, all right, would be equal to 180 degrees. 2x, what is my B1? My B is 120 and my C2 is x, 180 degrees. All right, so like terms, 2x plus that would give me 3x. Can I move the 120 over to the other side? So we have 180 minus 120, and that should give us what? 60 degrees. We can then divide both sides by 3, and x will be 20 degrees. All right, so our x is 20 degrees. Awesome. I think we have one or two more questions to look at. Okay, look at this. We need to find the value, all right, of x. We know that t1, okay, we know that the t1, let me write the 1 there, t1 is x, okay, and t2 is 50 degrees, all right, and trs is y. trs is y. All right, we want the value of x and y. Okay, now don't forget, okay, we are told that PQST is a rectangle. PQST is a rectangle. And what do you know about the angles, the interior angles? Each of the interior angle will be 90. Oh, T is equal to 90 degrees, interior angle of a triangle. Interior angle of a rectangle, rather, of a rectangle. Oh, can I then say x plus 50 equals to 90? And what does that mean? It simply means my x is 40 degrees. Done. That's quite easy now. All right. Now let's go find our y value. Okay, how do we find the y value? I see something here. It was hiding. If this is 90, oh, by the way, check this. There are two ways to say that. That angle is equal to x, which is 40 degrees. All right, either you use that or you can actually tell me that the triangle there will be 180. Oh, if I have that, look at the angle on a straight line here. Yes. Adjacent supplementary angles. But let's write everything first. V1 equals to 40. You can use alternate what? Angles. There are so many ways. It's not just one way. That's the thing about this geometry. You can actually find different ways of getting your answer, but at the end of the day, we should get the same answer. All right. Therefore, angle V would be equal to, since adjacent supplementary angles are equals to 180, all right, then angle V should be equal to 140. Why 140? Let's write it down nicely. Let's do this. V plus V1 would be equal to 180 adjacent sup. So what is V plus our V1 is 40? That is 180 degrees. So what is V? V is 140. But guys, we're not done. This is 140. I'm going to use a highlighter now. Look at the symbol that I have. Those lines are equal. And when you see two sides that are equal, then you look at the sides that are opposite the angles. Oh, this side is actually this angle is opposite this one of the side, so this is y. Now look at this other side that is equal, right? What angle is opposite? That is also y. Oh, awesome stuff. So let's have that. Now let's go work that out. So basically we are saying that y plus y, okay, before we say y plus y, angle S is equal to y. All right. If we say angle S looks too big, VSR is equal to y. So we're talking about that small angle there. All right. Angles opposite equal sides. So y plus y plus 140 should therefore be equal to 180. All right, angles, sum of angles in a triangle. So 2y equals to, can I move the 140 over? 180 minus 140 wouldn't give me 40. So y divided both sides by 2, y will be equal to 20 degrees. All right, done. We have, oh, here's the last question. All right, ACDE is a kite. All right, ACDE is a kite. Okay, and we know we're given that ABGQ is a square. All right, ABGQ is a square. AB, wait, let's interpret that. What do we know about a square? All the sides are equal, so that should be equal now. Okay, they didn't want to show that, but it's written in the statement. Okay, what else do we know? C1 plus C2 equals to 96, and oh, we are given that AC is 12 centimeters. AC is given as 12 centimeters. All right. The first thing is to calculate the length of AE with reasons. The length of AE with reasons. Okay. What do we know about a kite? It has four sides, all right, and we have adjacent sides. But we know that the adjacent sides are always equal. So AC, AE would be equal to AC, adjacent sides of a kite. All right, this is what I mean. If you have a kite this way, this side is equal to that side, and that is equal to that. So if you check, this is our A, and that's our C, and that's our E. So if this is 12, this is also going to be 12. All right, so A E would be equal to 12 centimeters, adjacent sides of a kite. Okay, so that is done. I'm going to just clone this page. All right, I've got another page there, and I'm going to clean all of this. Let's clean this. Okay, so already we have our first one. The length of GF. The length of GF. Look at GF. GF. We're working with GF now. All right. Now, if you look at AC, look at AC. AC is 12, right? And this line is divided into two, and we are told that this is equal to that. Automatically, can I say that is 6 and that is 6? So this is B. We're looking for GF, but we are told that it is a square. There's a square there, and we know that all the sides of a square are equal. So that would be what? 6GF. All right. I hope the explanation makes sense. All right. So what we will then say, AB equals to 6 centimeters. okay, which is half, and AB is equal to GF, which is equal to 6 centimeters. All right, sides of a square, or you can say opposite sides. You can opposite sides of PAM are equal. That's actually more correct. Opposite sides of parallelogram. All right, let me take this out. Opposite sides of parallelogram. Lovely. Okay, done. Beautiful. I have cloned that again. The sides of C1 and C2. The angles. We're looking for the angles C1 and C2. C1 and C2. All right. This is going to be quite hectic. We would not say that we would divide that angle into two. No, we're not going to say that. We are not going to say that that angle is divided into two. All right, C1 and C2. Now, what property of kite are we going to look at there? All right, one thing that we know is this, that the opposite side, it's also a parallelogram, that should also be equal to 96. But that will not really assist us in getting the angle there. Now, how then do we work out that angle C1 and C2? Okay, the first thing I see here is that, check this. I want you to see this carefully. I've got a square here. Let me use a green marker or a lime one. That angle there is 90 degrees because it is a square. All right. This angle also is 90 degrees. It is another square. So I've got a triangle that looks like this, and that's 90 degrees. Okay. And we are told that the two sides are equal, so this is B, C, and G. Now, if two sides are equal, you remember what we were talking about, angles opposite equal sides. This side is equal to this side. So what are the angles that are opposite those two sides? This and this. So this is my C1 and that's my G1. Those angles are equal, and this is 90 degrees. Oh, makes sense. So C1 is equal to G1. Angles opposite equal sides. But angle B plus angle C1 plus angle G1 should be equal to 180 degrees, sum of angles in a triangle. And my B is 90 already. Okay, since this C1 is equal to G1, can I say 2C1? Because we added them together, which is 180. All right, so 2C1 would be equal to 90 degrees. I have already moved my positive 90 over to the other side, and divide by 2. C1 will be 45. Oh, yeah. So now that I have my 45, I can get my C2. Can I do my C2 here? C1 plus C2 equals to 96. So 45 plus C2 would be 96. So what is my C2? 96 minus 45. And what would that give us? That would actually give us 41. But let's use a calculator. 96 minus 45. 51 rather. That will give us 51 degrees. And we have our C1 and C2. All right. And the final question for this session is to look for angle X. All right, we're looking for angle X. Okay, now that we have our C1 as 51, all right, oh no, I have this as 51. This angle here, okay, it's a kite, remember? it is a kite. And if it is a kite, let me extract my kite out. The side must be equal to that side. If this angle is 51, this angle also would be 51. Again, angles opposite, equal sides. So E2 is equal to 51 degrees. C2 plus E2 plus X equals to 180. So what is my C2? 51. What is my E2? 51. Oh, here we need a reason. Angles opposite, equal sides. 51 plus 51 equals to plus X equals to 180. What is X? Let's use a calculator. If I take the two 51s, minus 51 and minus 51, and we have 78 degrees, and we are done. So this is how we work out our geometry of 2Ds. Now in the next lesson, we are going to then look at what we call congruency and similarities of triangles. All right, goodbye.